Hi, I'm Dave and I'm going to do a review of the InWin RS424-02M server case. It's a 4-unit rack mount server with 24 bays for holding 3.5 inch or 2.5 inch drives. It has a 12 gigabit SAS3 backplane with a SAS expander for up to 24 drives. Internally there's space for two 2.5 inch drives for your operating system. It has a dual redundant power supply. Those are 875 watts each. It has 3 120mm fans which are hot swappable. It has a removable front bezel. It'll take an ATX or an EEB motherboard that's big enough for a dual processor motherboard. It has 7 full height PCI slots. It's made of 1.2mm steel and they claim it's a tool-free design. It comes with 26-inch rail kit. Hello everybody, so this is going to be an unboxing video of the InWin 24 bay rack mount chassis. It's going to replace my old chassis which was completely broken and never worked properly. This has a proper 24 gigabit backplane. No, got that completely wrong. It's a 12 gigabit backplane, not a 6 gigabit backplane which was in the Chinese case and totally doesn't work. So let's put this down and start unboxing. One of those. Let's have a look what we got in here. Okay, there. Let's make a bit of space. So what we got here? We've got an interesting box of something in here. So we've got a huge piece of journals piece of foam. Now this case weighs 22 kilograms. I know that it's particularly thick steel. It's a mid-depth chassis, so hopefully a lot more space than the old one. It's extremely heavy. Okay, I can't lift it. So, I've managed to extract it from the box after enhancing my muscles slightly, and this is it. So this is the InWin chassis. My old one was 55 centimeters deep, so this one is about 63.5, 64, something like that. Not including the front bit which sticks out unnecessarily. So that means it's bigger because it's a mid-depth rack mount chassis, and that's going to give us more space in the middle for the cables so that it doesn't get all mangled up and block the airflow like the last one did. So let's try and figure out how on earth we get into it. No instructions in the box. They're probably inside, which means you have to pass this test. So we have to figure out how we're going to get into it. We're going to have a nice peel later. We've got these here, which I suspect we're going to use to slide open the case somehow. Satisfaction. Now we know the unnecessary plastic. You know the nice bezel on the front of this does come off, which is what we want. We do want to take it off so that we can see the 24 bays on the front and so they get a decent airflow. But I have to say, it has got a great big hole. It's like an inch depth inside there, in front, between this front plastic and the front of the chassis, which means air can get in from the top and from the bottom before it blows across the drives. I'm guessing I have to open this. Let's have a go. And that didn't do anything. Ah, this did. There we go, it comes off. That's nice. Okay. So that means there's one little tiny grub screw at the back to keep the lid on. So what have we got inside? Well, we have in here two 800 watt redundant power supplies. You have a huge bunch of cables. Plenty of space here for an E88 motherboard. Hopefully space for 7, 1, 2, 3, 4, 5, 6, 7, yes, 7 PCI slots, which is great. A huge bag of silica gel to eat later. And we have our mid plane here with 3 hot swap, I think 120mm fans. And that's one of the really good things about this case, why I liked it, why I chose it, is because they are big 120mm fans, not like the 80mm fans that we stick in the other cases. So it means it's going to be quieter because the fans can run slower and maintain the same airflow front to back. So got a nice big clean backplane in the middle there, which is 12 gigabits, and I can see it's all been wired up pretty wide, which is nice. Connected already to the power supply. If you can see in here, they've got all the plugs already connected. Why are they in twos? I have no idea. Have I got 6? I should have 6 rows of hard drives for each 6, 12, 18, 24 drives. So 6, 1, 2, 3, 4, 5, 6. Yeah. But for some reason, 4 and 5 only have 1 plug. The others have 2 plugs. That's one of Earth's greatest mysteries. But it looks good. It's got a huge heatsink on the back of this backplane, which means, I guess, there's a processor under there to split the bandwidth of the 12 gigabits across the 24 drives. And we've got some interesting connectors. And already I can see my cable is not going to fit, because those are mini SAS HD connectors and there's 3 of them, not 4 of them. Okay, but I've got 4 on my controller card, which means I'm not going to get the full bandwidth. But it is 12 gigabits, so it's probably enough. We've got space here to mount what looks like probably 2.5 inch drives. Then you've got the removable redundant power supplies at the back. Hello, so what we got a European plug, which is no use. We've got another European plug, also no use. We've got what looks like a very strange little key. I don't know what that is, I have no idea. We have some jumpers. I know what they do. They jump things. We have, I think, are they no, they're not standoffs. Are they little screws for a motherboard? They look like standoffs for a motherboard. I'm not quite sure. Some stickers with numbers. We've got some zip ties and securing sticky things. We've got the usual motherboard chassis mount standoffs. There are the keys, that's what I'm looking for, so I can open the front. We have some screws with the old blue stuff's been applied there to make them tight and sticky. Seen those before. And oh yeah, look at these now, these are really good. So these will be for the 2.5 inch hard drives. These are the mini little grub screws that go in and don't stick out but hold your drive into the caddies. We've got 24 caddies, so it's about 3 million screws. Did you say how many? 88 did say how many. I apologise. And what we got here, same again. So these are for 3.5-inch drives and you get 96 of them. They were for 2.5-inch drives and you get 88 of them. That is because this server case actually takes both 2.5-inch and 3.5-inch drives in the caddies at the front. So that's good because actually I only needed 16 3.5-inch bays, but I thought, okay, where do I put my other 4 SSDs which are 2.5-inch? I can stick 2 in the back, but hey, I've got a spare 24 minus 16. Not looking at that, 8 bays spare at the front, so I can put SSDs in there, which is excellent. Small screws for chassis, 4 of them. Maybe they're spare ones like our little one that we had at the front. Okay, so found the keys. Let's have a look through the front chassis. Let's take this off. So let's unlock that. And that comes off. It does. Oh my gosh. You could sink a ship with that. That's so heavy. I mean, it's metal, it's really good quality. But I'm going to be leaving this off because I think it's just a bit unnecessary, really. The only thing it stops, it's good if you've got children around the house who like to touch things, because that will stop them from opening these drive bays. Let's have a look. It's oozing quality already. Yeah, okay, that's really good. So we've got ventilation space there, little springs, lots of mounting points, so you can mount your 2.5 or your 3.5. It tells you which screw points for which. That is useful. See, 3.5, 3.5, 3.5, 2.5, 2.5, 2.5. Why are the 3 points and not 4 for the 2.5? No idea. No, it's that one, isn't it? Because that's not aligned with that. I guess you mount in there's 3 screw points for the 2.5-inch drive, so that sits in there, because the interface could be the back on the right. Yeah, it is. It is. So let's just get the spare 2.5-inch drive. This is OCZ, terrible company. It's gone bust, and this one doesn't work anymore. But anyway, that would be sitting at the back of there, like that, which means, yeah, okay, yeah, so you see it's going to match up with the 3 mounting holes there, and that's fine, that's good, it's going to hold up. So if I were to put that in, it's going to connect at the back, which is really cool. So that is nice, smooth, 24 lovely bays. This does look really good, actually. Wow, and then we've got the hard drive light, access light, and what's that? Another light there as well. You'll never know because there's no manual. What else have we got on the front? So we got, I literally can't see that. They look like LAN access lights. Can it be? Has it got the management thing built in? I don't think so. What are they there for? I need glasses. I don't know what that says, but it's red. Red buttons usually not to be pressed. We've got a button on the left, button on the right, but we do have 2 USB 3 ports here on the right. There's a hole in the front of each caddy. Is that a lock? Yeah, it looks like it's a lock. So you can, is that what this other key is for? I guess it is. Is that what this? Can you lock an individual caddy to find it? Let's see. So it's called. How do you should put that close? No. Okay. How is that? I have no idea. Like that. It doesn't really work. Oh, it did work. It's locked. But it doesn't feel very positive. I don't know what I'm doing. I'm going to put that in there. It doesn't feel like it makes any connection with anything. But now it unlocks. So it does work. It's a bit plasticky. Oh yeah, it's very, you have to be really super gentle. If you're super gentle, you can feel the lock on it. So it's locked. Yeah, quarter turn. Unlocked. Okay, it does work. It works. That's good. So, we've unboxed the new rack server chassis, and we've got to transplant the old server into the new one. So, you're probably wondering, where is his rack mount server? I know, you can't see it anywhere, right? Well, you see this suspicious looking shelf? This is actually my secret room. And in here, if you come this way, you will find this is my StarTech trolley with my rack mount kit in. So this here is the old Chinese piece of junk, 16 bay, sold as 12 gigabit, but is actually 6 and may later completely fail. 16 bay hard swap chassis, which just doesn't work. So I need to power this off, and to do that I need to shut it down remotely because it's running a few virtual machines, so we can't just turn it off here. So we'll come back to this in a minute. You shut down. Thank you. Okay, it's gone. Let's just double check here. It's gone. Excellent. So now we're going to shut down the host. I can do it with my line, but why would I continue? Done. Okay, let's go and check it out. Okay, so let's open up my old case, which I can't wait to throw in the scrap heap. You can see the problem here, right? I don't need to explain it, do I? Seriously? So I'm going to strip this down. I'm going to take out first the motherboard. Let's transplant the motherboard into the new case. So, start plugging things. So the main problem with the old case is that it was always impossible to get the motherboard in, take the motherboard out, especially when you've got things like this, these SATA ports on the end of the board that don't face upwards, which is stupid because they catch in with the fan. You've got to be really careful with the cables, and it makes the motherboard impossible to get out of this case. It is a real nightmare. Okay, so we try to extract this motherboard from this terrible case. Doing things you should never do, like picking it up from cables, just to bend it that way, hopefully to get it past these fans here. There we go. Is it? Oh no! This is a terrible thing to do. I feel terrible. Oh gosh. Open it. It's out. Oops, something's still plugged in. So this case has a pair of redundant power supplies which come out like so. And what you have here is an 875 watt power supply, which is an 80 plus gold, super efficient, really small, and they both slot in together. So if one fails, the other one's going to carry on. Together, of course, collectively you've got like 1600 watts, but individually like 875. So if one does fail, your maximum output then is down to 875 watts. But that is going to be absolutely plenty to run this. So the fans are big, chunky 21 watt hot swap fans, which you can just pull out and drop back in really easily. They connect with a little circuit board type connector there to a normal 4-pin PWM connector, and this looks like this backplate will actually move. It has a secondary position there, which makes a lot of sense because we don't need all this space here, but we do need more space in the motherboard area. So I unscrew these thumb screws here, and I think that it's gonna unhook somehow, yeah, like that I think. So we try to move forwards, and that will give us more space for the motherboard at the back. Let's go here. you think? And we've still got decent clearance there between that back plane and the fans, and now we have more space in here, so when we go to put the motherboard in, we should hopefully have loads of space for those annoying cables at the back end here. I haven't put the posts in yet, but just to show you, yeah, so we've got a lot more room when that goes in. I'm not going to have problems with these cables here at the back. So let's install the posts and then that can be screwed into position. Okay, so they give you quite a lot of the little motherboard posts there. So we're going to install these. We need to work out where they go in here, the motherboard tray. So is it the usual 1, 2, 3? Usually 9. Oh, okay. We've got 2 there. Oh, I have to screw in. Whoopsie. Okay. So it's that one, and the top one there, isn't it? Bottom one, and that one there. Okay, so it's this one and the top one. Okay. Ah, I'm tangled. Help! Okay, so I think I said this one, didn't I? Let's try this end first. Come on. Yeah, that's it, that is in properly. Okay, now try again with this thing. So, actually, do they give you a different screw? Motherboard screws. They give you some nice motherboard screws, so I'm going to use these ones instead of the old ones, because these ones have the blue stuff on. Okay, not that one. Okay. Lots of room in this case. This is so much better. Power connectors and things. So this is the USB 3 header. This one, it's gonna go which way now? Much there. This one comes to the board. That's it. Here we have the big fat power connector, the motherboard. Oh gosh, what should we do here? Let's go under that. Let's go under those. Okay. Like so. Then we have a 4-pin PCI power plug here. Let's do this. Let's go this way. Oh, my back's hurt. No, it's in right. This is the 12 gigabit host bus adapter card, which has 4 ports, but this case only has 3. So I kind of feel as if I've wasted bandwidth. This needs to be. And our graphics card probably needs bending. Okay. They give you vented blanking plates. I was thinking about putting solid blanking plates in, but it's better to have the vented ones here because we've got plenty of holes in the back of this case for good airflow from front to back. But what we want is to have some airflow between these cards, because if we put something with some holes in here, then that's going to encourage the air to actually pass through between the cards and out the back. So I'm going to put the vented ones in. That's what they give you, so it's probably the best actually. They gave us, now here's a point with this case. They give you 2 SATA connectors for, presumably for these 2 drives here, but there are no Molex plugs. What do you do if you've got, okay, you won't have for this, is true, but if you've got extra fans and things, which I do have, I need to fit fans. I've got no way to power the fans. Okay, so with this case, they give you a little caddy here for putting 2 2.5-inch drives in for your operating system. It's going to be connected directly to the motherboard. And to be honest, I'm a bit disappointed because there's a lot of room in this case to have stacked these up. Maybe 4 would actually fit, because I mean it's double that would fit. And you could even have turned this sideways and had 4, 8, I can't count, 12. You could have had 12 SSDs in there. Okay, the airflow would not have been great, but I'm really disappointed with having just 2. So I don't know what I'm going to do. I'm going to have to come up with something which will probably involve Blu-Tack to add an extra 2 SSDs in that position. They've got the usual little blue thumb screw there, so they've got the keyholes with these posts, so you drop that in there, slide it back and it locks into place, and you use a little thumb screw to lock it in like that. So I'll do that later. I'll put my drives in there. So this case has the backplane having the mini SAS HD connectors on the backplane, which look like that. And a big shout out to Servercase UK, because they managed to give me some cables at the last minute just before they closed for the long weekend. And now I need to install these. These are going to connect onto my host bus adapter controller card in here, and the other end onto the backplane. I didn't have any of these, so I had to run up to Servercase UK before they close. That's what they look like, the mini SAS HD. So each one of these can control, I think, four drives, but this has a SAS expander, which means you actually can control way more than 4 drives. It's got only 3 ports, but it's driving 24 disks, so I'm a little bit concerned about the bandwidth and kind of wondering what's the point in having 12 gigabits if you only have 3 on there instead of 6. There should be 6 ports, not 3. It doesn't make sense to me. Okay, so we've got the mid-plane here, which I've moved forward so we get a lot more space for the motherboard and the cables on the back of the motherboard. But me being me, I didn't plan it very well. To get access to those ports there, I think it's probably easier if I just undo this once again. They've made it quite easy with these little blue thumb screws. Should pop out like that, and I could just hopefully just move it back. It goes on those little posts there. So what we'll do is we'll get our SAS HD cables, 3 of those for some strange reason instead of 6. Feed them through that little gap there. Oh, it's so professional. Okay. And we connect them onto these ports. I don't know if you can see them. These ports down here. So we've got the 3 mini HD SAS connectors. So I'm going to try to connect these on. So we clip that onto the second one. Come on. A mini little click sound. I'm not really worried about having the top port as port number 1 or anything like that. Okay, and the good thing about those connectors, what's better than the previous case, is these connectors are sideways. They're not this way, they're that way. That's now back in place. Okay, and I've got my SAS HD cables coming through here, which is great. All we have to do is attach them to the car. They're twice as long as necessary. These cables, by the way, are $14.99 each from Servercase UK, and apparently that's before VAT, so it costs about £72. Never mind. They're twice as long as they need to be, unfortunately. These are 60 centimetres. I think I only needed 30 centimetres, to be honest. So I think what we'll probably do is something like this. Put them in a loop. Let's put these out of the way. Over that side. We'll probably put them in a loop or something like this. It's a Broadcom SAS 9316i for 16 internal drives. I've had a few minor problems with it, but overall it seems good. They should have put a fan on it to begin with instead of me having to put a fan on, because it gets extremely hot. This heatsink gets so hot you can't touch it, so I'm a little bit worried about that. But I think in this case it should be a lot better than in the previous case, because the previous case had absolutely no room in it. So I need to find a place to plug that in, but there's no Molex plugs. So what I've done here is, instead of connecting the mid-plane fans onto the motherboard, I've actually used the 4 header points here on the back plane. There's 2 there and 2 there. They are 4-pin PWM connectors, which is really good. And of course I had the additional fan there on the SAS RAID controller, which I fitted. So I've been able to plug that on as well, which is why I've got 4 rather than 3. I've gone ahead and refitted my 2 Noctua 80mm fans in the rear, and I've put them in with a rubber silicone gasket in between the fan and the case. That reduces vibration and hopefully reduces any noise. Same on the back with the worm screws. I've used the little silicone washers. That should hopefully reduce vibrations. I've done some basic cable management, as you can see. I've used the little square stick-on brackets there and the zip tie to keep up the extra long SAS cables up at the side there, out of the way, so they don't hang down in the case. So it looks a bit tidier. And in the base I've done the same thing, just to pin down the SATA cables to keep them from sticking up, which looks a bit tidier. So the cables for the fans were originally coming out through this little pocket here, But what I've done, because I fed them back through and gone onto the fan headers here, what I've done is just left a loop so that if I ever want to bring them back into this side, then it's easy to just pull them back through. And also it reduces the length of the cable, so it's not hanging around in that space there, so it's all a bit tidier. I've also done some more cable management over on this side here. So I've clipped up my spare power connector there, so it's out of the way. The 2.5 inch caddy, which sits on top of the power supply, is only supposed to take two 2.5 inch drives, but actually each slot is about double the thickness of a thin Samsung SSD. So I quite easily managed to get 4 SSDs in there, and I've just used a little bit of blue tack to separate them, to keep them in place, stop them sliding around, because obviously 2 of them are not screwed in, they're loose, and it gives a bit of airflow between them as well. The problem we have got here is that these drives, we only have 2 SATA power connectors for these drives. We need power from somewhere else, but they don't give you any Molex connectors. Only this PCI Express plug here, 8 pin, and I don't have an adapter to convert that to a Molex or to a SATA. So we're going to have to hijack one of these. These are the powers going into the back plane. So I'm going to unplug this one and plug onto it my splitter. Is this the wrong way? What? Okay. Plug that splitter on there. These pins are always wonky, so they never go on. Never go on first time because the pins are wonky. They dance all over the place. Okay, there we go. So that's in there. Then we can stuff that down adequately there, and plug this back in here. Same wonky pin syndrome. We've got to get it just right, otherwise it won't go. Doesn't feel right. If it doesn't feel right, it's not right. That's better. There you go. Okay. Then this can come around here, and now we have some Molex power, which is good. Let's put that there in place. Okay, so then we need a SATA. That's a SATA splitter. We don't want that. We want this one, Molex to SATA. Now, by the way, these are the ones that you shouldn't use. I need to replace them. Notice these, which are molded in. They are a bit of a fire hazard. They've been known to catch fire, but we're only driving SSDs, so it's not a lot of current. Should be okay for now until I replace it. These molded ones are a bad design. The ones with the loose pins, as it is on that, they're a much better design. They don't catch fire. I found that out from a different YouTube video. Okay, so that goes on there, that way around, like so, and it's done. We have power. So I just wanted to see what the power supplies were like when you turn them on, because my concern obviously is the very small 40mm fans there versus the nice big 120mm fans, which we know are going to be hopefully relatively quiet. So I was just doing a power on test just to see. So that's one power supply going. It comes on initially a bit quick and then spins down. And you can see that there's an AC light flashing there. That's the one that is not powered up yet. The one with the solid light on the top is the one that's powered up. If I now switch on the other one, again you get the initial fan spin up. Now we have 2 solid green lights. So I wanted to do a power on test of this case just to see if it's quiet or loud, I have no idea what it's going to be like, but we've got all our fans installed now. We've got 3 on the mid-plane, the 2 noctules at the back, and of course the 2 little power supply fans. So let's give it a go, see what it's like. Oh dear, that's loud. But you know what's loud is the power supply fans. I can hear the high-pitched sound. They're spinning down now. Now what I can hear is the mid-plane fans. Okay, it keeps changing speed, which is strange, but I guess because they are 4-pin PWM fans, it's going louder again. Probably it's detecting, no, because I haven't got the drives in yet, so maybe it is the room temperature. It's 23 degrees in here. It's getting louder and louder. Oh dear. Oh, it's been down again. What? It's crazy. It has a mind of its own. Okay, when the fans are at low speed, then the noise is really acceptable. Obviously with the lid on it'll be quieter. And one important thing of course is that when you've got the lid on, your airflow is much better because it's contained. So it can only come in the front and go out the back, and that cools all of your components, whereas with the lid off it's not actually cooling any components, so it will get hotter. So these are the rails that come with the InWin chassis. It says InWin Rotterdam on it. They're the 26-inch rail kit. They are adjustable, so they fit a full depth rack, as well as my mini Diddy one. And this is how they come inside: a pair of rails and 3 bags of screws. And let me show you these rails. They're a very good design. I'm very impressed with the rails, more so than the case. The rails are really good actually. Tool-free design on rails. Go away. Okay, so let's see which way around it is. Okay. So this is a right-hand rail, and that's the back, this is the front, so they pull out like that. It is, I think it's a 4-rail, 1, 2, 3, yeah, there's a 4th one there. It's actually a 4-rail system, very soft, easy glide, ball bearings, really nice. It's locked out into that position, or that one is locked into that. And there's a button to release it just there, so you slide that back and then that will go into there. And that middle one is, it does lock here. The middle one's locked in position until, it's very clever, until this gets along as far as that catch there, because when you press that catch down, then the middle rail will also start to slide in like that. And it's a tool-free design, so we've got keyhole slots, 1, 2, 3, 4, 5, which go onto the case and clips on. You've got the usual rack points at both ends, so now I'm going to try to fit that onto my case. It is adjustable. There's 2 nuts and bolts there and there, so you can expand or shrink that gap there to fit your rack. So inside the rails box there were 3 nice little bags. These are the screws for attaching to the case, which you don't need because the case doesn't actually have screw holes in, so that's good, you don't need that. You've got your cage nuts here, and these are the bolts to go in the cage nuts. But what I'm curious about is what size they give you, because I've had horrendous trouble with American imperial size screws, not metric screws. We hope that they're M6, but they might be something strange. So I have this little tool here, which was given to me free, thanks courtesy of Rack Solutions. Thank you for that. It's a little tester, so you put your screws in there and you can find out what size they are. So I'm just going to do that now. Good news! They're M6 screws, which is standard machine screws, metric. So that means my rack system is going to be consistent now. Thank you. Okay, so we're going to install this rail here in the bottom of the rack. So it's a 4U chassis, and we put the rail in the bottom 3 pegs here. So first thing to do is make sure you got it the right way around. So the rails are coming out the front like that. The front is on the left on here. Now what I do, I don't know, I guess it's convention. Generally speaking, apart from this APC UTS at the bottom, all of the other brackets are on the outside. So these, I'm going to sit them here on the outside, which means I put the cage nuts on the inside. So that's the first thing to do, take our cage nuts, and they're going to go in holes 1 and 3 of the bottom slot here. Okay, so we're going to go in these 3 holes here. If we just check that alignment, oops, see, I was wrong already. Not this hole, but these 3 here. So we want our cage nuts to be in here on the inside, like so. Fat fingers. 1 in there, and 1 in there. And then that's going to go on the outside, like so, like that. And then we screw that in from behind. The length of this is going to need adjustment because it's too long at the moment for my rack. Our 2 nuts, again, going to go on the inside here. So, pops in there. And that pops in there. No, is it wrong? I got it wrong. See? The importance of aligning your holes. That one and that one. Does that look right now? Yeah, that looks right. Okay. Now we need to adjust this because this depth, as you can see, is not right. Now what I've done wrong is I forgot to take the innermost rail out first and put it onto the server, which makes it much easier. But what you have to do to take this out is you extend this fully, then push it back in gently, and then is it this one? What's the button? Yeah, pull that out this way towards the front, and then that inner rail slides out like that. So that's going to attach onto the side of the server chassis later. So put this to one side. Now this we need to adjust next. So where we have these 2 nuts coming through here, those we're going to have to get access to on the other side, which you can only do after taking the inner rail out. Then you could just undo them with a screwdriver from the inside, like so. Keep the nut safe. Take the screw out, don't lose it. And same with the other one, because I'm gonna, I think, do I adjust that one on the other side? I can't remember. Let's try leaving that in, but we need to slacken it, I think, because it will slide to a point. I think we do need to take it out. Yeah, you see, it doesn't go back far enough to fit the front of this, so we do need to take this one out. We'll reposition these so that our bracket matches the front of the rack. Okay, so that is now a separate piece. But what we're going to do is we're going to be screwing it on the front, so putting that in position. Now what you can do to cheat, I know you're probably not supposed to, but you can screw this in to the rack already. Don't lose the screws! You can screw it in from the front so that it doesn't wobble around when you're trying to match it up to the rack. Like that. as well to stop it from twisting. I'm trying to make it look like I know what I'm doing. Okay, so what we want to always try to do with these rack brackets is go as far into the center as possible, because that gives you more support. So it looks like I'm lucky to use this hole here. I just need to slide the inner bracket along to be able to get access to that hole. So that hole is there, so I need to slide this along to, that's it, so I can see the hole from this side, and then put my screw through like that, and the nut on the outside like that. And then the next one, I think this one here, I think can come through there, can come through there. And here, this one is partially blocked, this one is clear, so we're going to use this one. Put the nut on the outside. Okay, tighten that up from the inside. So you may have to slide the rail along a little bit. This one should be tight because we don't want it to sag in the middle. That's really important. Okay. Now what I'm going to do later, I don't know if you can see it down here, at the moment our supports for this back bracket are right down at the far end. They're right down here. And what I'd like to do is bring this one much further forwards to one of these earlier hole positions, because that will give us a lot more support. Okay, so we want to move this one further in towards the center, or towards the front of the rack, to give it more support. So first thing to do is slide the rail back on the inside so that you can get to the screw. Unscrew that. Follow the nuts. Okay. I have to do it. Now we need to find a hole where we can come through here as far forward as possible. So this one is blocked at the front, you can see. That one we can't come through, but we can come through. There's a hole here. So let's see, I can get, yeah, I've slid the rail along so I can come through that one there. So put the screw through from the inside, put the nut on, like that. The thing is, my hands have gone all greasy from the rails, so it's a bit difficult to tighten things up, but that's it, that's done. Okay, now what we can do is tighten our nuts at the front and at the back. Okay, so this is the inner rail. I'm just going to show you how this clips onto the chassis. It's a really good design, I have to say. It's got these keyholes, so we just have to line it up. Make sure you get the blue tab to the front. Line that up over there, and slide it back, and it's clipped on. Done. So these rails are a really good design. Once they're on, they're locked on, they don't move, they don't come off, but you can easily remove them just by pressing on this little spring here, as you can see, that way, like that, doing one-handed. Yeah, one-handed doesn't work too well. There you go. So I was going to say it's tool free, but you don't have to do any screwing. It fits onto those little pegs there, which is really good. So I've finally taken out all 16 discs from my old rack mount chassis, and here they are, ready to go in the new machine as the old pile of screws. And now I have to do the same job, putting them back in the caddies for the new case. Okay, so we're done. The rails are on both sides and we're ready to stick it in the servo chassis rack thing. So first of all, a satisfying peel. Okay, now we can put the lid on. Now this lid has got, as you can see, two fancy catches there with the buttons at the top. So they actually latch in to this strip of metal here, and I guess we just drop it on and slide it forwards. Maybe we push the buttons in. Do we? Use more power maybe? No, doesn't work. Okay, how does it work? Button presses it down. Nothing blocking it, nothing's jamming it. No strawberry jam. Now they go under the front of these here and here, so it should. Perhaps I have to press the buttons down a little bit more. Or is that not kept on properly? Ah, that feels better. Okay, still doesn't push the buttons in. Of course, you could read the instruction manual to find out how to do this, but they didn't provide one. How on earth? I don't understand. Why does that overhang on both sides? What am I doing wrong? Okay, before I break my back trying to lift this into my rack, I'm going to try to make it a little bit lighter. So these redundant power supplies, I'm going to take them out. You squeeze the green tab and pull by the handle. There we are, on gold PSU. They're relatively light, so why am I taking them out? But never mind. Okay, both out. Okay, this is the bit where I become a disabled person. It's very heavy, but I'm going to lift it in. It's the only way to do it. It's got to slide into the rails from the front, on both sides. Oh god, this is going to be difficult. Never lift with your back, always lift with your legs. And always have 10 extra hands handy. Get in. It's not going in on this side. Right, going. Oh yes. Finally. Oh my gosh. What? What? What do you want now? Why has it stopped? It's hit something and it's stopped. I don't know why. The inner rails have gone all the way in. I've still got a problem with this stupid lid. No matter how hard I try, this lid will not go on. It gets as far as there and doesn't go any further. I've tried pressing these buttons in with two hands and using my third arm to try to push that along, but it doesn't work. So the lid still doesn't go on. I have just removed the little tabs to figure out if the reason why the lid won't go on is to do with the mechanism that latches the lid on. Obviously it isn't, because it's still, no matter how hard you press, you can't close this gap here. So really I am completely at my wit's end trying to figure out how to put the lid on. So it's day 3 of trying to put the lid on, and I've taken the fans out to see if that's the reason. Maybe they are too proud, sticking up too much, although I don't believe so. And well, to be honest, I just tried the lid already and it still doesn't fit, so I can't figure it out. Well, it's day 4 of trying to put the lid on. I think I've just figured out what the problem is, and I feel incredibly stupid. So it's the screws from these 80mm fans in the back of the case. The screw positions are very close, they're right at the top of the case, and the back panel has a lip on the back that goes all the way down, and that is clashing with the screws, the wide screws there. Right, this case is not going to beat me. I have power tools. I'm going to cut a notch for the worm screw heads, because even if I were to change them for smaller screws, this stupid lip on the back of the lid is still going to catch, and I'm not having it. So, plus it's a pain to take the whole servo out to take the worm screws out, so I'm not doing that. I'm just going to cut a notch in the back of this stupid lid. Here we go. Right, now I'm going to bend these over and then it's going to fit. Right, so I've just finished the mutilation of this back lip, bending this out like so. That one, this is a double one. Yeah, there's a double one for the middle. There we go. Okay. While the case is out, I did just want to show you the problem with the worm screws for the 80mm fans and the top lip of the case. If you look really closely, what you can see is the top lip of the case goes right down to the center line of the screw. So it doesn't matter how small screws you use, that lid is never going to go on. Yeah, even if you use really flat head screws, not these dome head ones I've got, the lid will still never slide all the way forwards. It's going to jam on those screws, there's no way around it, so that's why I decided to modify the lid slightly. Let's put the case back in. Right, so try this lid now, see what it looks now. Don't fit. Ugh. Oh my gosh. Okay. There's a bulge in the middle. But it goes up now. Okay. Okay, so I'm just about to put the servo back, and to me it looks like it's sagging a little bit, as you can see, facing downward. And one of the problems that I know I have with this is it gets stuck on the unit I have below there, which is the UPS. When I try to push this back in, it's not going to go. I have to do some difficult positions and lift the back end up as I push it in, otherwise it won't go in. Okay, so let's try to get this back in. Oh god, backbreaker. And yeah, it's stuck. It's stuck on the back. Oh god, I can't believe this. So I think I have to just lift it up at the back like that to get it on. Now, there's no handles, and you've got to be so careful because the power button's on the front. Slide it in. Oh god, it's done that again. And it's jammed again, which actually I wanted to demonstrate. It gets stuck at this point with a big clank, and you have to press both of the blue tabs at the same time, which is difficult if you're in a small spot. If you can't get right in front of the machine, you can't do it. Pull both tabs forwards. Now it's jammed, you have to pull it out again and then pull the tabs forwards, and then it will go in like that. And it's powered up. Turn it off, turn it off, pan it, turn it off. Because turn it off. Thank you. And the lid's opened. As you can see, the gap has reappeared again. Doesn't close properly. And another problem we have is that when you're trying to push it in with your hand goes on the power button, which is there. So to fix the lid again. Okay, let's push this back all the way. Oh, it doesn't go all the way. Ah, what's happened here? Well, the rails are all the way in, but the case design doesn't go back to the rack. What's going on? I don't understand it, because it has these flaps here, and that is for screwing the front onto the rail, as you can see. But how would that work when this doesn't go all the way to there? There's a great big gap. I don't understand. It won't go back anymore because the rail is all the way in, but the rest of the server, the machine, as you can see, is sticking forwards. So what gives? I don't understand. You put this all the way in, it stops there, and if you look at the top here, it leaves a great big, it's like an inch of it sticking out the top. Okay, right, let's put the power supplies back in. One and two. Then we need our kettle plugs. Two kettle plugs. One, two. You have to plug both in, otherwise it complains. And they're going to go into our UPS over here, and we'll sort the cabling out later. A few more things to do here. One, two. Okay, assuming I live with it sticking out, let's power it up and see what it looks like. So all the bays initially light up blue and red, and then just the bays which have drives in remain blue, and I think the access light is green, but we need to wait for this to start up. The fan does keep changing its speed, like it's trying to calibrate the temperature or something. Well, there we go, you can see the access lights now. They're green, as you can tell. There we go. Fan keeps changing speed all the time. So I had wired up this power button. This has the power button and this second button which says ID on it. I'd actually wired that up as a reset button, which works for me. Turns out, after reading the manual, that the reset button is this, and that is a cocktail stick job. There's no way to press that button at all unless you've got something to put in there. So although it should be wired to this one, I'm just going to leave my reset button on the ID. This ID button is something to do with daisy chaining together a bunch of chassis using the expander backplanes, so you could have one host and many chassis with many arrays of discs in it. One important test: we need to make sure that there is enough air current flow from front to back to cool those drives. So we do the paper test, and the paper sticks. That's a good sign. So we, even with the fans running slowly, there is enough air current, I think, through there. What we need to see to prove that is the hard drive temperatures. So we'll check that next. Let's check that again. Okay, that's alright. So we got the air conditioner on here, Fujitsu. And for the sound problem, I have a little bit of soundproof insulation foam, which may help. So this is the manual for the back plane, and actually it's quite complicated. As I wanted to show you that it has a section here on the ports, the mini SAS connectors. So the model I have, the 24 bay, has 2 input ports and 1 output port for cascading down to another unit. So initially I made a mistake because I didn't have the manual. I connected all 3. Nothing bad happened, but I guess it was only using the top 2, so I suppose you should only connect the top 2. Okay, so after reading the manual, I discovered that actually on this back plane in this machine, the connectors for the SAS HD plugs, it turns out although there's 3 and I plugged all 3 in, I'm stupid because actually it's 2 in and 1 out for a SAS expander in another machine. So what we have to do down here is unplug one of these, not just any one. After reading the manual, it's the bottom one that is the output, not the inputs. All of the others are inputs and the bottom one is an output. So we need to unplug the bottom one. Of course it has to be the bottom one, doesn't it? So let's take this fan out and see if we can reach this one here. Press the clip. Oh my gosh, you need impossibly small fingers. Always happens to me. There we go, I've done it. So what I'm going to do is I'm just going to leave that in there just in case. I mean, I don't need the cable for anything, in case I ever want to add another unit at any point. So plug this fan back in here. There we go, and put the lid back on. Yeah, everything else is good. I should actually, while I'm at it, now that I'm finished, I'm going to put the grub screw in there so the lid actually stays on and doesn't slide off. It still does not actually, same problem as before. It doesn't come all the way to the front. So I don't know if I'm going to get the screw in, but I'm going to try now. Right, let's get this microscopic screw back in here. Little grub screw, keep the lid on so it doesn't open when you pull the unit out. Carefully. Okay. Now this is the fun part. I'm trying to put it back in here because watch, it's stuck. Again, because the rails sag, so I think I have to lift it up on both sides here. There we go. And when you slide it in, you've got to be so careful not to press the power button, because the power button's in a stupid place and it's jammed again. And when it jams, you've got to pull the blue tabs forwards, but you can't. This one here won't go forwards. It's stuck. To get around now, you have to pull the unit out a bit again, and then you can pull them forwards and then push the whole unit in. And this keeps happening. And I powered it on by accident. Oh god. It's so tight. And that's as far as it goes. Still got this gap here. The perils of rack hardware. So I'm trying to figure out why it's sagging. You can see the rail here for the new server is ever so slightly down here in the middle, a millimeter or 2 compared to the other side. I'll try to adjust it by slackening these bolts, bringing it up a bit and tightening them again. But you notice what's worse is this gap here between the new server and the old server at the top. You can see the gap at the back is quite big, gap at the front is quite small. And that's because what's happened there is the old server is much worse with the old rails. These rails don't have as much support and they've sagged quite badly at the front. So the front is low down, which is why I think it's tight when you're... It's not the reason it initially jams when you're trying to put it in. It's the reason why it gets tight as you get sort of halfway in, I think. So I'll try to straighten things up a little bit. So we can see on this one that we've got a gap at the top here which shouldn't be there, and at the bottom, where's the bottom here, it seems to have sagged down a little bit. So what I'm going to try to do, being an ape, is use a door wedge to shift this up a little bit while I slacken those nuts and tighten them up again and see if we can bring it up a little bit. That's actually working. The door wedge in there has raised it up and closed the gap at the top. So now I'm going to tighten the nuts. So I tightened the nuts, but as soon as I pulled out the door wedge, it dropped down again. You see you've got the gap at the top there. This is the case and the rails that came from X case, and I just think it's not very good quality. It's all a bit flimsy, the brackets are not long enough, so I don't know. I'm going to try tightening the other side, see if it makes a difference. So I'm making a bit of progress here. I took out the old server, the old X case, and the old brackets were attached with simple nuts and bolts, which is not very good. So what I've done is I put proper black cage nuts in, and I'm going to use some black M6 bolts here to go in the front, and that will stabilize it, I hope. And also what I noticed is that these rails, these old rails, are set back slightly from the front of the case, and when I compare that to the new server's rails, which even protrude slightly from the front, I'm thinking that maybe they should be set back. Maybe it's a question of adjusting that to set the rails in, and that will close this gap here. So I'm gonna tidy this up, replicate the same on the other side, and then I'm probably gonna have to take this beast out again to do the same with the bottom rails to make it consistent. So the old rail's now been secured in place with proper black cage nuts and M6 bolts, and I'm trying to replicate the same thing on the other side. And originally here we had, let me just move around, this rail was actually inconsistent because it was further forwards, right to the front of the cage, whereas this one, as you can see, is slightly set back. So I'm trying to replicate the same thing on the other side before I do it on my new case below. And I've noticed that the secret is loosening the bolts which hold the brackets onto the rails. So there's one at the rear, way down there. That was the key one actually. Undoing that one now allows this whole rail can actually move. Ignore the front plate, but luckily you can see that mid rail now can actually be adjusted forwards and backwards. So then I can get that in the right position where I want it, and then bring this one forwards. I'm going to mount it there like that. Now if you've never seen how the rack mounting system works, I'm going to demonstrate that hopefully with one hand. You get your cage nuts here. You could get black or silver, and they need to pop into the holes. So we're going into number 8. So we need one in the bottom, one in the top. So the idea is you you place it in there, and then you have to, it's a spring clip it in there like that. Get another one. Same for the bottom, and which way around they go, by the way. Obviously spring clip goes into the holes, and I put them on from behind so that you can then screw in, oh dear, you can screw in the bolts from the front. I'll drop the nuts. So once you've got the cage nuts in the two holes, top and bottom, then you can line up whatever rails you're mounting with those holes. Put the bolt through the front there. I'm doing this with one hand, no cameraman. There you go, like that. And then obviously before you tighten it, you want to make sure that's hold it in exactly the right position firmly. It should be dead center between the lines there. So now that's secured tightly at the front, what I can do now is bring the mid rail there forwards to the same position as it is on the other side, which is about there, and then we can tighten up all the stupid little nuts and bolts and keep this thing together. There's one there and there's one buried in the front as well. We'll tighten those up and the one on the back. Now obviously to get access to the screw, you need to slide the rail along until you find a hole where you can access the screw from this side. It's a real pain because you've got to put a screwdriver in that side and hold it at the same time as tightening the nut on this side. It's really awkward. So I'm looking at getting the in-win 23-inch rails for the other Ks, but I've noticed compatible models brand in-win models only. That means that we can't use these on the old case, so we'll probably have to go for some generic rails. They're not going to be as good. I hope they don't mount on the front, I hope they don't mount on the back. I hope they do mount on the front like the others, but I don't know which one to get. Help! So I'm going to give them a call. So I've loosened this bracket to enable me to adjust this. The point we're interested in is, of course, where are you? This here, not the innermost rail, the outermost rail that's going into the mountain bracket. We need to decide where is the front of that. So in its adjustable position now, the very front it'll sit at is that there, that point, and if I push this back, it's locked, the little one is locked, that'll go back as far as there. So it's very tricky. The way I reached that point where we're adjustable between these two extremities is by taking out the nut and bolt that was in a fixed hole at this end, and it was in a fixed hole at that end there, which prevented it from sliding further back, and here prevented it from sliding anywhere at all. So as you know, it was sticking out originally about an inch, and that's because the distance between this, which we want in contact with the front of the rack, distance between there and the start of the rail is about an inch. It's 25 millimeters. So that's exactly what we need to replicate with the position of the rail in the rack. So it looks like this position is right, I think. That is an inch to the front of the case. The third hole in here matching up with a fixed hole on the inside. So the other thing that I found is that with these spring washer bolts that they give you, even though that is really tight, as you can see it isn't tight. Not happy. I found that when you change it for normal ones, it doesn't do that. So now both sides have been adjusted. So that's set back 1 inch and that's set back 1 inch. So hopefully now when I put the case in, it should sit flush. So I put the case back in on the repositioned rails, and from the front it looks better, because now I can actually just see the metal casing on my UPS below it, which means it appears to have gone back flush, but actually there is still a gap here. But looking at it, I'm not sure, because from above, certainly, like, it matches the UPS below it. Still not very happy about the positioning, but it's a lot better than it was before. So I think I'm just going to leave it at that now. Put the drives back in. I had to take the drives out because I couldn't lift the case. This is real back-breaking work. Just in case you're curious what it looked like without the drives in, you can see at the back there the back plane with the SATA 3 terminals, connectors. Sorry, SAS I should say. They've got the notch in the middle, which enables you to plug a SAS drive in, and they've got little shelves for the caddies to sit on. So it's quite a nice design. In case you've never seen it before, the drive in the caddy goes like this. It's screwed in 4 places on the bottom, and just slots in on the shelf, one-handed like that. Okay, slide all the way into the back and then push that to lock in position. So the good news is that after running the server all night, I can't hear it. The noise is actually my workstation down here. There's a very faint fan noise coming from the door, but really quiet. Let's have a look. The fans are still on low speed, so that's not bad, that's good. As you can see, the hard drive temperatures have gone up. The highest now is 46 degrees, which I'm not very happy about. It's probably in the middle somewhere where the heat can't escape. This means the fans are not quick enough, and it's got this built-in fan controller. There's not a lot I can do about it other than disconnect the fans and put them on the motherboard and control the speed that way. So one thing that annoys me with the case is that the fans are running too slowly all the time, and the drives are right up to 42 degrees. I'd rather the fans run a little bit quicker and the drives be a bit cooler, even though it will be slightly noisier. I would prefer that. I found the page in the manual for the fan speed. It's got here the cooling policy and how it works, and I am a bit confused because right at the top end here you've got 42 degrees. It's considered highest or second highest, so it should be running at 60 or 70%, but it isn't. So if it was, you'd know about it. So I don't know. I would like to recalibrate or adjust the speed ratios, and I don't know how to do that. It doesn't tell you how to do that in the manual, although there is quite a lot of stuff in it. This is how to upgrade the firmware. You can upgrade it through this SCSI bus. Maybe I should try that actually. The thermistors, but the temperature sensors are here on the board. They seem to be in a sensible place. So they're in between drives, somewhere in the middle here. Haven't seen exactly where they are on my board. So they should be detecting the heat from the hard drives, and it should really ramp up the fans. It's not really happening, so I'm going to play around with it. Maybe I'll try upgrading the firmware. And I was reviewing my cooling, and I realized something, that I had connected this homemade fan here. I had connected it via this extension cable to the headers on the backplane, but the headers on the backplane are not running at full speed most of the time. So for that teeny weeny little fan there, it probably isn't doing very much. So I'm going to take that off the fan header there, and I'm going to put it on the motherboard and on that connector down there. I'm also going to try to do the same with the others, but I don't really have enough fan headers to do it, because the other three 120mm fans there, they're running at very slow speed all the time because the back plane says so. I'm not happy with that. My drives are still too hot, so I want to take those headers off there and connect them directly on the motherboard, or I certainly can't do them at full speed all the time. That's the tricky bit, because that would be too loud. So I do need to regulate the speed, which means I need to find the 4-pin headers. I have to use the PWM headers, and there's one I can see over there, and there's one for the CPU fan down there. The others are not 4-pin headers, so I don't know what I'm going to do unless I buy a fan controller. It's all really annoying. So I need to cut the zip tie to get that cable out, and I thought it worth mentioning that if you want to cut a zip tie, don't ram scissors into it or try and rip it apart like an ape. It's good to use these particular pliers here. These will allow you to cut without risking damage to the cable underneath. So my CPU fan is connected to a 4-pin header right down there, CPU fan 1. I'm going to take that off, and I'm going to put that on that 3-pin header down there by the SLI logo. So the CPU fan will always run at full speed, but it's a little Noctua one. It's not going to be really loud, unlike those beasties. So then that will allow me to connect, let's say, this one as if it was my CPU fan onto that 4-pin header down there. Then I'm going to use over here, there's a chassis fan, a 4-pin, sorry, the cable's in the way, the 4-pin chassis connector there. I'll use for another fan, maybe this back one here, which means this one will be the only one left controlled by the silly backplane. So because the big noisy 120mm fans are on CPU fan 1 and chassis fan 1, I'm setting those to silent mode, and I'm leaving the others at full speed because those are the small Noctua fans that are quiet anyway. So we'll see how this goes. If we find that the hard drives get too hot, we can always customize the profiles in here. So that's the silent profile, that's the standard one, performance and full speed. So this means it's going to run, if I leave it in silent mode, it's going to run at about 35% power, whereas standard mode is like 60% power, 65. So let's see how it goes on silent, and we'll check the hard drive temperatures. So to test the fans, I did a Z-Pool scrub, and I left it going for about half an hour and checked the temperatures afterwards, and the highest there is about 47 degrees Celsius. This is on the silent mode profile, so that's not good enough for me. I want them cooler than that, so I'm going to go back and change the settings in the BIOS. So I've realised that the drives on the top are really cool, because at the moment I've taken the server above out, and I've noticed that obviously I've got the 8 unused bays at the bottom, so the last row is also cool, but I think what's happening is the discs in the middle are running hotter. Now one reason I think this may be is because there's very little air resistance in these 8 trays here. If I take one out, for example, you can see the air is going to be able to flow very easily through those, and therefore that will be less airflow through the others because it takes the path of least resistance. So I think I need to actually partially block these up to simulate having drives in there in order to have a uniform airflow across all of those drive bays. Indeed, if I feel the temperature of at the bottom of one of these drives, that's really cool. So I think there's a lot of airflow going through that bottom section there. So I think the solution is actually to put a restriction in there. So I've taken the caddies out of the case and I've got a block of foam from the packaging, and I'm going to slice this up into little blocks that will sit in these trays and block the airflow as if they had drives in them. Now I've made foam blocks for all 8 of these caddies and cut them nicely to size so they sit inside. They shouldn't catch inside the case. Right, that's the last of the foam blocks in the remaining caddies. So, in the manual for the backplane, they give you a reference to the Linux SCSI generic driver, and this will enable you to do any operation on the SCSI bus, such as upgrading the firmware of the backplane, monitoring the temperatures, and so forth. You need to scroll down to the SG3 utilities and locate the links for the Debian packages. These work on Debian, on Proxmox, on Ubuntu, on anything which is a derivative of Debian. So because I'm using Proxmox, I can use this. Copy the link address for the first one. Then we need to go to our terminal. I use MOBA Xterm because it's absolutely brilliant. And then we want to download using that link, like so, using wget. And then go back to the browser, and we come back here and we want to download the libgutils as well. So right click again, copy the link address and go back to your terminal. We do another wget and paste the link, the second link. Now we have the 2 Debian packages downloaded, we just need to install them. So we can install the library first by doing dpackage-i libgutils, press enter, it's installed. Then we can install the other one, the SG3 utils, dpackage-i SG3 utils, and they're all installed. You can see the SG3 utils commands by doing an ls on the user bin directory. Now the next thing we need to figure out is which is our SCSI device. So if you do ls SCSI, you see all of the disks attached to your system, and one of them, here you'll notice on ID number 16, is the actual InWin enclosure itself. Now this, you'll notice, doesn't by default show you a device name, so to get the device name we have to do ls SCSI -g, and this tells us the SG names for all of these devices. So the one we want, the InWin enclosure, is dev SG16. You can also do, for example, SCSI temperature, dev, let's go for the first hard drive, just to show you this example, dev SG0. That shows us the temperature of the first hard drive. But if we want to get the temperature of the enclosure itself, that would be SG16. Unfortunately, it doesn't work. This is where I'm currently stuck with InWin support. I'm waiting for them to get back to me because the fan speeds are not running quickly enough, because it thinks probably the temperature is too low for the trigger. So ideally we need to read the temperature off the backplane to find out what temperature it thinks it is in there. You can also get your hard drive temperatures using the HDDTemp utility, which is the one I use, because you can put a pattern. You can say dev SD ? And you get all of your disks, and here it's just complaining about the SSDs that they don't have a temperature sensor, which is correct, and that's fine, you can ignore those errors. So all of the Seagate drives, my 16 3.5 inch 6 terabyte drives, they all report back with good temperatures. I also like to check that my zpool is healthy. You can do zpool -v status. No. Zpool status -v tells you the status of your ZFS pools and file systems, and you can see there's no errors there, so that's fine. So on Servercase UK, they do have quite a really big range of server chassis available. Filtering here by the InWin4U units, they do quite a good selection indeed. This is the one I've gone for, the InWin RM424 for you, it's got space for 24 hard drives, 3.5 inch or 2.5 inch. Let's have a look. I got it with the rail kit, and I got it with the 800 watt redundant PSU, which is actually not listed here. It is expensive. I mean, even before you add on the redundant PSU, it's extremely expensive. It's good kit, I have to say. And the best thing about this, the reason that I've chosen it, is because it officially supports the 12 gig SAS. Where is that gone? I'm just going to show you. Yeah, it officially supports 12 gigabit SAS on the back plane here, and this front bezel is removable. So the RS424 from InWin is also available on the Scan website for $1,259, which is £500 less than what I've paid from Servercase UK. So I asked Servercase UK, and they said, well, they buy from us. So how does that work? They're making a loss, but I believe it is ordered on demand. We think that when you order this, they're going to say, oh no, we can't really do it for that price. And just to show you, there are quite a range of alternatives. I was quite surprised that just how many server cases are available on the Scan website. From the top end, Supermicro 45 bay, right down to, well, bits and bobs. Single units. Oh, that's expensive for single. Okay, so quite a selection. I'm surprised at the price of the Supermicro cases, to be honest, because it looks like I could have had a Supermicro 24 bay with a 920 watt 80 plus gold PSU for $11.29. So part of me kind of regrets maybe not going for this one. Although, to be honest, when I look at it, I don't know. 24 bay. Is it 6? Oh, I bet it's 6 gigabit. That's the deal. I've noticed this problem a lot, that nobody has a 12 gigabit SAS. Does it even say anywhere? Do they know what they're selling? It doesn't say. But I would bet you that this only has a 6 gigabit SAS backplane, and it just doesn't say anywhere. No, it doesn't say. And that's the big deal. That's what's taken me so long to find a case which has the 12 gigabit backplane. I wanted that specifically because of the problems I've had using the SAS3 drives in the old X case. The problem with the third pin out being powered, because it doesn't officially support SAS3, and if you power pin 3 on the plug, then it goes into power saving mode, which is a really stupid idea. You can find more information on that on the web. So if you're going to use SAS3 drives, you have to make sure that your chassis supports SAS3. And SAS3, of course, is the 24 gigabit backplane, not the 6 with SAS2. So I just don't trust it if it's not SAS3. So there's the InWin, cheaper price. We've got some Supermicro alternatives, a bit cheaper as well, around about the £1,000 mark. And quite a surprising selection of rack mount chassis cases. They even do an entry-level budget one here. They do actually publicise this one as 6 gigabit. Logic Case is actually a brand of Servercase UK, so again they are buying these cases from Servercase UK, and this is a very good price for a budget case. But the difference, of course, is it's 6 gigabit. So if you're willing to just run SAS2 drives and you're happy with 6 gigabit, then this is really good value for money. It's a nice case, and you can look at their site, by the way, Logic Case. I think they've got different sites. I believe they've got 4 brands going on, but it's the same company. So a rack mount 4 unit high. Here we go. So these are the budget cases here. Logic Case is the brand name of their custom made budget cases. So what was that one? That was what's the model number? 4324S, which is that here? This one here. It's this one. 4324S. Sorry, the S. So that's what you're looking at there. It's the same thing. Okay. So, good selection on both Servercase UK and Logic Case. So I bought my original case from Xcase, and they have a selection of budget price point cases. So they're trying to compete against Inwin and Shenbro and those big manufacturers. They are much cheaper, I have to say, but there is a difference I think, in the build quality. And what concerns me really is that you don't really know exactly what you're getting when it comes to the back plane and everything. I've noticed if you look at what's their flagship one here, okay, the most expensive, this guy, the RM424, named suspiciously like the one from Servercase UK, which is the Inwin RM424. It's a 24 bay chassis with the 12 gigabit SAS expander backplane. So this is the equivalent of the one that I've already gone for from Servercase UK. It looks extremely similar to the Inwin one. I do wonder if Inwin are also making this but not putting their badge on it, or if they've made a copy, and therefore you don't really know what you're getting when it comes to the backplane. The interior design is exactly the same, the removable 120mm fans, except the Inwin ones are blue plastic, these are black plastic and have nice yellow stickers on them. But yeah, redundant PSU, just the same as the Inwin, exactly the same design there. The mid plane, is it adjustable? I think they've got a couple of pegs there. I think it's the same. I think you can step it forward just like on the Inwin. Oh look, there's the same heatsink on the centre, so it could be. Who's to say if it's a copy or it's an Inwin backplane? We'll never know. But it is described very similar. So you've got the 8643 mini SAS connectors, 2 in and 1 out for expansion. Requires only a 4 or 8 port. Well, that's not exactly true. It's 2 ports of mini SAS. Okay, 4 ports of the old, not the HD SAS plugs. To run 24 drives with the built-in expander. Yeah. 24 bay, 12 gigabit backplane with expander built in, and SGPIO, and the 120mm fans. This has the 800 watt redundant PSU, including the rails. So it is, on the face of it, it's a good deal when you compare it to the price from Servercase UK. I mean, it's £1,700. It's eye-watering. So you're saving £700. So you do have to ask yourself, why? What's different? Is Inwin just overpriced, or are we getting something different in the innards of this thing? Just to go back, just to show you the alternatives that they do. So if you knock off the redundant power supply, that gets you down, that saves you £250–300, £742 for this one, including the 12 gigabit backplane and the SAS expander. 24 bay, everything else is exactly the same, just without the redundant PSU. And then if you take away the expander backplane and go for a standard backplane, that's going to save you another £250, so the price comes down to £502, which is, wow. It's directly connected, if you think about it, from your host bus adapter or your RAID card straight to the drives. So it is, the base chassis is an expensive chassis, but still, when you compare it to the price of the official in-win from Servercase UK, this is less than a third of the price. What do you get for that? Well, it seems to be exactly the same. Can I make this bigger? No. It's the same, except you don't have the expander, and that means that you have 6, where did it say, I saw this earlier, there are 6 plugs, I believe. Yeah, here we go. Chassis has 12 gigabit backplane with 6 8643 connectors, so that means they're being driven directly from the card. So really, this is just like a straight pass-through. I don't think it's got any of the clever logic. It probably doesn't have that processor with that suspicious heatsink in the middle. It's just going to be a straight pass-through. But everything else about the physical chassis is the same, except of course on this one you don't have the redundant power supply. So if you're looking for a cheaper option, this could be a good option. So what's my final thoughts and conclusions about this case? Well, what I like is that it's much better than the previous case I had from X-Case. It's got a very good build quality. It's got those nice caddies that are good design. It's also the only case I could find with a SAS 3 12 gigabit backplane. All of the others online are 6 gigabit. There's lots of space inside the case, which I like. The mid plane that holds the fans is adjustable in 3 different positions. The fans are easy to remove and to put back. The caddies are individually lockable with the little key. The bezel is also lockable. The rails are a very good design, tool-free onto the chassis, but obviously not onto the rack. So what don't I like about this case? Well, there's quite a few things, unfortunately. You can't adjust the fan profile. You can't make them go faster or slower for a specific temperature. There's no way to edit it. I can't find a way to update the firmware as yet. The drives are running too hot as a result, so I had to unplug them from the backplane and put them onto the motherboard. I don't like the way the lid on the top closes, and it's not tool free because you need a screwdriver to put the grub screw in. The screw holes for the 80mm fans on the back clash with the lid, so the lid doesn't go on properly unless you modify the lid. It doesn't take a standard ATX power supply, which means you do have to get their own in-win power supply or the dual redundant power supplies. Internally, there's not enough bays for 2.5-inch SSD drives. It only officially holds 2, and you could have fitted 12 or 24 in there quite easily. The front bezel is rather heavy and unnecessary, and it's not hinged, so it's all or nothing. It's either on or off. The plastic lock for the caddies is a bit kind of flimsy. It doesn't feel very positive when you're trying to lock those individual caddies. I kind of don't see the point in that. And finally, it's very, very expensive. So, final marks for this case. For performance, I'll give it an 8 because I still have a doubt about why there's only 2 SAS HD input plugs. For design, I'll give it 6, and for value, I'll give it 4. I don't know if there's any better cases out there, but I would definitely like to try Supermicro next.